After knowing that the name of the array is treated by Java system as a collection of variables, also after knowing that we need to know an index of an element inside the array, and altogether the name of the array followed by an index is referred to an indexed variable. Now we need to go into more technical details and some recommendations. First, when creating an array, instead of using an integer literal, like an integer constant, it is better that you use a named constant. The reason is that if you have declared an array multiple times in your program in different places with the same integer literal, then later if you change your mind and you want to change the size and the declaration of these arrays, then you have to look into your program for these declarations and change the size of these arrays one at a time. However, if you define the size of these arrays as a named constant, and later you change your mind and you want to change the size of these arrays, there is no need to look for their declarations in your program. Simply go and change the value of the name constant for the new value. This will make dealing with arrays in your program much easier than if you declare them multiple times with integer literal. Sometimes you don't know the size of the array ahead of time. So how you are going to declare such an array? In other words, if you don't know how large to make an array when you write a program, what to do? There are two options. The first option is that you can read the array's length from the keyboard. Here is an example. We print a message to the user asking how many temperatures do you have. We read the answer into an integer variable size. And according to the value entered by the user, we declare an array of this size. However, sometimes even the user doesn't know how many elements he or she is going to enter. And this happens in sentinel-controlled while loop. We ask the user to enter a set of numbers followed by a sentinel. So we don't know how many numbers the user is going to enter. In this case, this is the other option as a solution. You can allocate enough number of elements, so you declare your array with a predefined number of elements, large number, and use a counter as an integer to keep track of the number of used elements of the array. So this is like the maximum number of elements that you have in your array, but you are not necessarily going to use all of these elements. Therefore, you define a variable count as an integer, you assign 0 into it in the beginning. And every time you read a number from the user, you save it into the array. At the same time, you increment count by 1. Now to keep a track of how many elements did you use of the array, you simply refer to that by the value inside count. In this way, you are guaranteed that you have enough space. At the same time, you don't need to know in advance how many elements to declare in the array. But be careful when you do this, because when you keep incrementing count and exceed the limit of the allocated elements in the array, then your index will be out of bound. Therefore, when you create a loop for reading numbers followed by a sentinel, not only you put a condition for testing for the sentinel, also test that the number of elements entered by the user should not exceed the number of elements that you have used in the declaration of your array. Doing this, it is guaranteed that the loop will stop whenever a sentinel is entered by the user or whenever the value of count exceeded the allocated size of the array, and you will be in the safe side that you never enter more than what's allocated in the array. Since reading data input from the user and saving this data into an array is often demanded in many questions deal with arrays, we would like to show you how to implement these two options on our temperature program introduced in today's lecture using JGrasp. This is the program for the temperatures example. The program is asking to enter exactly 7 temperatures. Therefore, our program is hard-coded with the constant 7. What does it mean by hard-coded with the constant 7? Hard-coded with the constant 7 means that the array size is coded by a fixed value rather than a variable, which makes it difficult to change or alter without modifying the program. In other words, it can handle exactly 7 temperatures. And if you want to change this number to another number, then you need to modify your program, compile it, and run it again, which makes it less flexible and impossible to use with different sizes of temperatures. Notice that we are declaring an array of size exactly 7. We are writing a loop that repeats exactly 7 times. Also, the average, we are dividing the sum over 7. Also, whenever we want to check the temperature, if it is above, below, or equal to the average, also we have created a loop that repeats 7 times. Now we will make our program more flexible. In option number 1, we will ask the user to tell us how many temperatures do you want to enter. First, we change the message and we will ask the user how many temperatures do you want to enter, assuming that we know the number of temperatures in advance. And we are going to read on the same line and we will change colon into question mark. We will read this number into a variable. I'm going to call it count. This is equal to keyboard because the name of the scanner keyboard dot next integer. And now our program for the arrays will depend on count, not on the constant 7. So therefore, I will cut the declaration for the array, and instead of declaring an array of size exactly 7, we will declare an array of size count. So it depends on what the user is giving us as an input. We will declare an array of that size. Let us remove the spaces here. And now let's go over the program and remove all constants and replace them by this size. So we need to compute the average, the loop to go from 0 less than count. And also after we compute the summation, we divide summation by count. And if we want to compare each temperature with the average, we go to its loop and also change it to count. Let us run it. So now the program is asking for how many temperatures do you want to enter. We want to say that we want to enter 4 temperatures. Now I think there is a missing message that we have to print to the user to tell the user, please enter 4 temperatures. So this is missing. Let us just put some values for testing. The program is working fine. Let us go back after reading count. Then we need a message to tell the user system.out.println, and we will tell the user please enter, and we need to print the value of count, temperatures, and we enclose the message. Now we will run it again. Now it is asking how many temperatures do you want to enter. We will say 4. Now here it says please enter 4 temperatures. So we will say 4.6, 7.8, 9.0, and 4.5. Also, you can refine your program. You can put a message inside the loop and you can say please enter temperature 1, please enter temperature 2, and etc. So let us do that as another option. I will remove this message and then we will go inside the loop and we will say system.out.print. We are going to read on the same line, please enter temperature, and I will put hash, and after hash I want to print the number of the temperature. Now from where can I get the number of the temperature? We can get it from the index variable, which is the loop variable. So here we write index followed by a colon because we are going to read on the same line and we want to separate the input from the message. But notice that index starts from 0. So a message will appear on the screen. It says please enter temperature number 0. number 1. But the user doesn't know about the program. You are the programmer and you know that arrays start from 0, but usually users are familiar to start from 1. Therefore, you need to change here, and instead of printing index, you print the next number, which is index plus 1. So if index is 0, it will print 1. If index is 1, it will print 2. And when it reaches the last index, which is not equal to count, when you add 1, it will reach to count and it will tell you the last temperature. Now we will run it. And now it's asking for how many temperatures. We will say 4. Now here it says, please enter temperature number 1, 45.6, temperature number 2, temperature number 3, and temperature number 4. It will print the average and it will compare all the temperatures against the average. The second approach or option, we estimate how many temperatures our program can handle, and we will use this number as the size of the array. We will define this size as a named constant. So outside main, we will define this constant, public, static, final, integer, and we will call it size, and it will be equal. Let's estimate that our program can handle 10,000 temperatures. According to this number, we are going to define an array of this size. So we remove 7 and we put the name constant as the size of the array. It's better that instead of defining variables anywhere in our program, we put them in one place. And I will put that, and I will put all the variables in the beginning. So this area, I'm going to say data declaration. We will take the scanner and paste it in this area. Also, we will keep the array declaration. We will also take the definition for the summation, place it here. Also, we need a variable that keeps a track of how many temperatures we are going to read from the user, and we will call it count, like what we have done for the first option. And this count should be initialized to 0. And then we have to change the way of reading from the user, because we don't know exactly how many temperatures we are going to read from the user. We will depend on sentinel controlled while loop. We will tell the user to enter a set of temperatures ended by a sentinel. So we will display a message by saying enter a set of temperature values ended by, and now we need to choose a sentinel that does not represent a realistic temperature. We will choose 5 nines because we don't have a temperature with this number, and we will use it as a sentinel. We will display this message to the user, and as you recall that for sentinel controlled while loops, we read the first temperature, we test it against the sentinel. If it is not equal to the sentinel, we enter the loop and repeatedly read the next temperatures. Now, we don't have a variable that holds the temperature. We need to define it, and I'm going to define it with sum because it's double, and I'm going to call it next. Then we will read from the user the first temperature by using the keyboard scanner. Next, double. And instead of for loop, we are going to write a while loop testing for the sentinel, while next is not equal to 9999, 4 nines. And by the way, we can define the sentinel as named constant as well, but we will leave it as it is now. And then we will remove the for loop and replace it by this while loop. And again, for sentinel controlled while loop, we have to, at the end, read the next value inside the loop. By looking inside the loop, we should remove the reading from the user and replace it by next, because we already have read the first temperature and saved it into next. Each temperature, we read it from the user, we need to save it into the array. So how to save the data into the array. Previously, we were using the index of the for loop, but now we have to think about something different. We will use the variable count because count initially is 0, then we need to save in the first element. When count becomes 1 for the next temperature, we need to save into index 1. So therefore, we will use count as index, and this value of index should be updated for each temperature. So therefore, here we need to write count plus a plus. Let us see now how it works. When we read the first temperature, count is 0. So where are we going to save this temperature? We are going to save it into index 0. Then we will increment it by 1. And the next reading for the next temperature will be saved into the value of count. It was 0, now it becomes 1. That means we are going to save the next temperature in the next variable inside the array, and so on. We need to go to the program now, and instead of using the constants, we need to put instead the number of temperatures we have read from the user, which is saved into count. And again, for the loop that compares all temperatures against the average, also we need to change the loop variable that it goes up to count. Notice that for the second loop, we are using for loop. Why we are using for loop? Because we know that we have exactly count number of temperatures. However, for the while loop, for the sentinel controlled while loop, we don't know in advance how many temperatures the user is going to enter. So we cannot use for loop in this case. The last thing we need to think about, which is critical, is that we have to make sure that count should not go out of bound. In other words, we will ask the user to enter a set of temperatures, but in our code, we have to make sure that the number of temperatures should not exceed the expected number of temperatures that our program can handle. And how to check for this? We check for this inside the condition of the while loop. In addition, for testing for a sentinel, we will also check that count should never exceed the value of size. Yes, you are allowed to enter a set of temperature values, but do not exceed the size of the array because we don't have a space for more than the size of the array. Let us check now the program. It seems that we have mistyped double. So here we should have double. And let's check the syntax again. And again, because I copied it, next double. Run it again. So now it does not have any errors. We will run it. It will tell us to enter a set of temperature values ended by the sentinel. We will put 90.5, 67.5, 89.0, 45.6. Let's say minus 9.0. Now we want to terminate reading. We put the sentinel and we press enter. And as you see, it has printed the average and tested for all temperatures against the average. And by the way, this approach has many practical situations, especially if you want to read the temperatures from a file and you don't know the size of the temperatures inside the file. So we can use this approach by reading the temperatures from the file until we reach the end of file. Let us continue and present more programming techniques on array. Next, in general, it is better that you use singular names for arrays. Since arrays hold more than one element, it seems to make sense to give them plural names rather than singular name. However, this creates confusion when referring to individual indexed variables, and programmers find that their programs reads better if they use a singular form of an array name, like the following example. Here we are declaring an array for marks. See the name, it is a plural. This is valid, but it is not nice. Why? Because if you want to refer to individual mark, you write marks between brackets a number. However, they are not marks, it is only one mark. So it is nicer that instead of defining the name of an array plural, you define it singular. Now here is the nicer definition or nicer declaration that now when you refer to index variables or elements in the array, you write mark between brackets the index. So when you say mark 1, so it makes sense that we are referring to an individual element rather than a collection of elements. Also, the singular form works better when the array name is used in some sort of computation. In this case, the name refers to only one element, not the whole array or the whole elements. Let us refer to our mark array. Programmers find that their programs reads better by writing mark I equal to 3 instead of marks I equal to 3. Why? Because mark I refers to a single mark. However, if you write marks I, then it refers to more than one mark. Therefore, when you print the mark, you say the mark is, and it is singular when you refer to indexed variables. But this is not always the case. It is not a rule that we should follow for every array. It depends on the context of where we are using this array. For example, if we want to define an array for number of hours worked by employees, then we are going to define an array called hours. Here, it is better that we give plural name, not singular name, so that when we refer to individual elements or individual employees by saying hours 1, for example, then it makes sense that we are referring to not 1 hour, more than 1 hour. In Java, you know the syntax for creating objects from a classes. You write the name of the class, followed by a reference variable, followed by equal, followed by the keyword new, and then followed by the constructor. Now, when you write new followed by the constructor, this is the ignition to the system to create an object, and its address is assigned to the reference variable. Now, if you don't include equal in new followed by the constructor, then the system will not create any object. It will just define a variable in the memory, and this variable will be just a reference to this type of the class. Now, when you create an array of objects, it doesn't really create any instances of these objects. However, it creates only empty references of these objects. And in Java, empty references are referenced by a special value which is called null. Here is an example. We are creating 5 references to circle objects. But in fact, if you go to individual elements of this array, none of these elements is in fact pointing to any object. So we are not creating 5 objects. We are just creating a place for 5 references. In other words, if you want to make this array or elements of this array points to objects, then you have to go over the elements one by one and create an object for each of these elements. Here is how to do this thing. For example, if I want to create an object in the first element of the array, remember that the first element of the array refers to a circle object. And if you want to create an object and makes this variable or element points to this object, you write circle 0 equal new circle 3.4. In this case, the system will create an object of circle. The radius is 3.4 and its address is assigned to the first element of the array. And for the second line, it will create an object of type circle. The initial radius is 5.6 and its address is assigned to the reference circle 1. So the index variables of the array in fact pointing to objects. And when you create an array of objects, in fact you are creating an array of empty references. We have mentioned before that arrays were objects. Therefore, we could expect that they have data members as well as public methods. However, they have only one public instance variable, and that variable represents the length of the array. So what is the length of the array and how to determine the length of the array? When you declare arrays, part of the declaration you specify how many elements you want to create from this array. Now this number represents the length, and in programming, whenever you want to refer to this number, you can refer it by this public instance variable. So this public instance variable represents the length of the array which contains the number of elements in the array. This instance variable is final, that means it is constant and its value cannot be changed. Therefore, you can use it for reading, and especially you can use it inside loops if you want to go over the array from the beginning to the end. When you declare an array of a certain size, in programming, how to reference the length of this array. Here is an example showing you how to reference the length of an array. In this line, we are creating an array of integers of size 3. Now, when we ask you what is the length of this array, then the answer will be 3. So 3 is in fact the length of the array. Now, in programming, how to reference the length of an array? You reference the length of the array by the instance variable length. You just write the name of the array followed by dot, followed by the instance variable length. And here is how to print the length of the array we have just declared in this line. When you write the name of the array is list. Therefore, list.length will give you the size of the array, which is 3. Previously, when we were using loops to process arrays, we were using constants for the length of the arrays. Since we have an instance variable that can give us the length of the array, then it's better that we use it instead of using constants. The reason is that if you use a constant in your for loop and later you redefine the array, I mean you allocate a new size for the array, then you have to go to the loop and change also this constant to the new size of the array. However, if you use the instance variable length in your loop, you will have the advantage that there is no need to change this loop whenever you redefine your array to a new size. Let me demonstrate of what I have just said by an example in JGrasp. As an example, let us first define an array of doubles, and we will call it number, and let us declare it with, for example, let's say 10 double values. I want to now generate random numbers and save them into the array. So we write a for statement. I will be the first index of the array, and I less than 10, which is the size of the array, I plus. In each iteration, we will say number I is equal to math.random. Now, suppose you redefined the array with different size. Suppose you said that number, you don't need to define it again here because you have already defined it up. So you can just use the name of the array without redefining it. Otherwise, you will get syntax error. Suppose here you have created another one, but this time we will have different size. Let's say, for example, 5. In the beginning, you defined a reference to an array pointing to 10 double values, but now you have redefined the array with the new array of size 5. Now again, if you want to generate random numbers and save them into this array, you will repeat the same loop, but this time you will put 5 because we have 5 elements, and we will save into this array like what we have done before, math.random. So as you see that every time you redefine the array, then the loop will be different. However, if you use length instead of the literal constant, then it will be much easier and more flexible to deal with your for loop for arrays. So here instead you just simply say number.length. And also in here you don't need to look of what is the size of the new array. Simply you say number.length. This way, it makes writing for loops for arrays much easier and more flexible. Another advantage of using length instance variable for arrays is that when we pass arrays to methods. We will talk in more detail about passing arrays to methods later. However, it is not a problem if we introduce it now, and then later we will talk about it in detail. So let us assume that we want to print the elements of the array. So we use for loop. So I will copy the for loop, and we will write a for loop for printing, and we will change this statement into system.out.println, and we are going to print the index variable I. Similarly, we are going to copy this code for the other array after we have redefined it, and we are going to repeat this code. Since the code is repeated, so we will put this code into a method. I'm going to delete it, and then we will call this method. We will define the method in the same class where main is defined. We are going to define it public void, and we are going to call it a print. And the input parameter will be an array of double because we want to print an array of double. So we write double with empty brackets, and we give it a name. I'm going to give it the name num. And inside, we will put the code that we have deleted and inserted inside, but we need to change the name of the array. Instead of number, we are going to call it num. So whenever we want to write the elements of the array, all what we do, we simply call the method. So inside or after we generated the random numbers, here we say print, and we give the name of the array number. And also for the redefined array, we call print by the name of the array, and the method will print the elements of the array. See the flexibility here when we deal with length with arrays. When we call the method print, there is no need to tell a print what is the size of the array because it is referenced by length. However, previously, if you wanted to print and if you don't use length, then you have to supply another parameter here that tells the method that this is the size of the array. So now it is more flexible to deal with the array by using length rather than using literal integers. Before we continue and run the program, notice that the method print is called from within main, and main is static, so therefore we have to define a print as a static. Otherwise, we are going to have a syntax error. So now let us compile. So now there are no errors. Now when we run it, so as you can see, all elements of the arrays are printed one after the other. If I want to separate the printing from one array to another one, then here we can add a new line inside the print. We say system.out.println, and now we run it again to separate the output between arrays. Now we are coming back to our example, and this is how to print the values of the array list using the length instance variable in a for loop. We simply write list.length instead of writing a 3. We know that when you create an object of integers, the system will initialize all of these elements of the array to zeros. Therefore, the output of this code, it will print all zeros on the output screen. The question is, do we really need to use length for every for loop that we want to use to process an array? The answer is no. If the array is completely used for your data, then you can use length in your for loops. However, if your array is partially used for your data and the size of the data used in the array is controlled by a count variable, therefore, it is not correct to use the instance variable length to process your array because length, it does not represent the size of the data, it represents the size of the whole array. Notice that the data size is smaller than the array size. Therefore, when you want to process the array, you use the variable count in your for loop. We have mentioned that the instance variable length is final and its value cannot be changed anytime in your program. Therefore, remember that you cannot assign a value to the instance variable length. And if you try to assign a value to this instance variable, then you will get a syntax error because it will be an illegal statement. Here are some tips about arrays. First is index of first array element is always 0, and last valid index is always the length of the array minus 1. So therefore, in for loops for processing arrays, for the condition, Instead of writing the index is less than or equal to array length minus 1, we simply say that array is less than without equal is less than array.length. Therefore, when you process arrays, make sure that array indices must be within bounds to be valid. Otherwise, when a program tries to access outside bounds, you are going to have runtime errors. If you are processing an array using a for loop and you already know the length of the array, either by using the instance variable length or by using a counter that keeps track of number of elements that you have used in the array, then this problem is implicitly avoided. Why? Because your loop is already starting from 0 and it will never exceed the bound of the array because we are using length or count of the array elements. Just remember that array indices must be within bounds to be valid, either when you read data into the array or when you process arrays. Since the index of the first element in a Java array is always 0, the last index number is not the length of the array, but is 1 less than the length of the array. This is why in loops we write less than array name.length. Therefore, be sure that your indices stay within this range. So far, we have seen how to declare an array with a certain size. Also, we have seen how to read data from the user and save them into the array using for loops. Now the question is how to initialize an array during declaration. At the time of declaring your array, how to put initial values. This is the way syntactically to do it in Java. First, you declare the array with its data type. You give it a reference, you put equal, and then you put the initial values between curly braces. So to understand what is saved into the array, 3.3 will be saved in index 0, 15.8 will be saved in index 1, and 9.7 will be saved into index 2. The length of this array is 3, so when you call the instance variable length, reading.length will be equal to 3. Another way to initialize the array elements with a certain value is that you use assignment statements, but you have to go over the elements one at a time, and to do this you do it in a loop. And you have already seen plenty of examples that we were doing this technique to assign values into arrays. After you define the array and allocate a certain size for this array, you go over the elements one by one using a for loop, and the index will allow you to visit the elements one after the other. In each visit, you just simply put this value into this element. So here in this code, we are initializing all array elements to 0. And by the way, when you define an array without initializing during declaration, like in this declaration, by default, the system will initialize all these elements to 0. So you don't need this for loop to initialize array elements to 0, but this is only for demonstration. However, if you want to initialize all elements by a certain value, then you need to do it by yourself using a for loop.